Hello everyone, my name is Prabsimar Kaur and in this task I am demonstrating multiple interrupts along with timer interrupts on the Arduino Nano 33 IoT. Now let's discuss what are interrupts and why are they helpful than polling. So basically polling means when a microcontroller keeps checking a pin or a condition repeatedly in a loop to check if something has happened, like button press or a sensor is triggered, so which basically wastes CPU timings and the microcontroller may miss fast events. So there is the interrupt comes into play. Interrupts solve this by automatically running a special function when an event occurs, so the microcontroller doesn't waste time. Now let's see the hardware system of this so of this system. Now as you can see, I have used a button plus two sensors, that is DHT22 and light sensor. The button pin is connected on the digital pin 2 and the other two sensor like the light sensor is connected to the pin 3 and DHT is connected to the pin 5. The DHT sensor basically handles the timer interrupts and the light sensor handles the external interrupts. Along with that, LEDs are also connected that show the output pins to show the interrupt response. Along with that, resistors are used in order to make the system reliable. Now let us have a look on the code of this system. So I have used RTC0 library, which is used for timer interrupts like LED toggling and periodic logging. We have used attach interrupt function here that is used to assign in ISRs, that is interrupt service routines, to external pins. So basically ISR is a special function that runs automatically when an interrupt occurs. We don't call ISR manually, the microcontroller jumps to it at the moment the event happens. ISRs are used because they react instantly, they have an immediate response, they don't require polling, basically don't waste the CPU timing, and they are reliable because they won't miss any fast events. Like in our function we are toggling LEDs and logging events, like DHT sensor readings are logging on the serial monitor because we have used ISRs. Now let me explain you what are timer interrupts, as we have connected the DHT sensor to the timer interrupt. So basically timer interrupt is an automatically trigger that generated at a fixed interval of times, like we have given 2 seconds of interval of logging the data into the serial monitor to the sensor. Now let me show you the serial monitor, so you can see the readings plus the triggering timer interrupt that is handled by the DHT sensor and the light sensor readings. As you can see the serial monitor, we are getting the light level, and if we have covered the light sensor or not is also being seen on the serial monitor. As if we cover it, it says it's too dark, and if don't cover it, it says too light, and it also gives the reading of the light sensor in terms of lux readings. Plus you can also see the DHT22 reading and the green for blinking, like it shows it is using green LED for the blinking purpose. Continuously the readings are being changed. Now let me show you the live demo of the readings, so you can see how these readings are getting on the serial monitor. See, firstly we have covered the light sensor, which is triggering the green LED, and also there is the notification going on the serial monitor. And continuously the red LED is toggling because of the DHT readings. Sorry, the red LED is toggling because of the light sensor, and the green LED is toggling because of the DHT readings. Then you can see the serial monitor. As we are pressing the button, the notification plus the green LED, other green LED is also blinking, and we are getting the notification on the serial monitor. In conclusion, we can say that interrupts are quite useful when we are seeking immediate responses to the inputs. Plus, they are quite efficient than polling, as no CPU memory and timing is wasted for repeatedly checking any trigger. Plus, timer interrupts allow to check the precise periodic task. Thus, this makes it essential for real-time applications where we can use interrupts. Thank you.